so this is the model we use.
So this is just, we use the sponge as kind of a base. We just use skewers to stick it in. So this is kind of our crane. Use the pin to, and then here's our bucket. And so we filled it with water till the outriggers here on the bottom. These are our outriggers until these ones here tipped over. And so that's basically the model, the string to keep it propped up.
So, oh gosh. First we solved for the weight at which the model tipped by finding the moment at point B.
And so we did this by kind of experimentally finding our center of gravity through the way that Dr. Zoran showed us on his video. This is where our line is marked. So as you can see, the entire model from outrigger to outrigger is about 6.5 plus 12 centimeters, so it's 18.5 centimeters long.
Yes. And next we found the area of the plate. To do this, we found the moment at point A, and using that, we used Dr. Zoran's equation right here. RB/2 equals 100 kilonewtons. So we found...
We did RB/2 because there's 2 outriggers at point B. So you have to, when you find the reaction, you actually have to divide it by 2 so you can get the reaction at the individual outrigger.
Yes, so doing so, we found the area of the plate to be 2.9 times 10 to the negative 5 meters squared.
Right. And then based on his next question, he asked if the weight of the tipping point, if we were to double the weight here, how much of a counterweight would we have to add? And so it was very similar to how we solved the first part here, where you just kind of use the moments at point B, but instead you now have a counterweight right here. So you put that right at outrigger A just to make the calculation simple. So that way when you solve for the moment at point B, you just set it equal to 0 because it should be in equilibrium, theoretically. And so you just take the moments and then you solve for the counterweight, and so we got 0.84 newtons based on what we had. And so just to kind of cap off the last 2 questions, would the plates be enough? Simply because we're not working with a lot of weights. The thumbtacks that we used as plates would still work. They wouldn't crack under the double the weight. And however, theoretically, could the plate fail in a different way? Sure. The sponge isn't super tough, and the thumbtacks themselves can get old over time.